It's
Yes, sir.
Okay. I thought that I was not unmuted. Okay, no problem. So mutex is a lock. More specifically speaking, it is a binary lock. So mutex is generally implemented by two different types of software kind of issues. One is acquire the lock, ACQUIRE, acquire that particular lock. Acquire is a particular function. Whomever the operating system developers, they are supposed to implement acquire is the particular piece of code, so which can be implemented by so the people who are implement the operating systems. Okay, acquire is one particular law, and the release is a second one. Release is a second one here. Okay, now these are the two locks. When acquire is supposed to be taken, it is always looking forward to the. Let me take this one. Looking forward to the a global location. Let me draw a small diagram for you to understand in a better way. So this is your random access memory. For example, you please draw. You please draw. This is a random access memory, and here it is. Operating system has decided to run this entire process here, and our process one is somewhere else. I'm drawing here. You can draw somewhere else. There is no problem at all. And process two was so resided somewhere else. Let me say this is process two, and now so mutex will be mutex is the particular what you call lock which is going to store somewhere else here. So mutex. So let me give you what is the full form of mutex after some time. So mutex is the particular thing here. By default, this particular thing will be so false. So let me write outside of this one. So by default, it should be equal to FALSC. Please write in inside because I am unable to so fit into this. False is not able to fit into this box. That is why I have written outside. Okay, by default, the mutex is false. So what do you mean by false here in the sense? So I wanted to execute its critical section. Any kind of process can be access this lock because it is by default it is false. So lock is available for the people. Lock is open for the people. So therefore, once you have to acquire the lock, once you have to capture the lock will be closed. Once lock will be closed, I mean, if room is there, if room is open, anybody can enter. If room is closed, you could not enter. Something like that. Mutex is false in the sense lock is open. If lock is open, anybody can acquire that particular lock. So make that mutex false to true. When it is true, obviously no other people are supposed to enter into that particular room. Let me say the critical section. Okay, that is the point what we have to understand here. Okay, then so acquire is always trying to so take the sense the lock here, sense this particular mutex lock here. Whether this is true, then the process what is the process where exactly so acquire is supposed to be applied as a piece of code will be in deadlock mode. Deadlock in the sense waiting mode. When it is true, when this particular thing is true, then obviously the process which is operating acquire will be put into waiting mode. When this particular thing is false, mutex is false, whatever the process which is being accessed or executed this acquire, so then the process will be enter into critical section. Let me write the piece of code here how the operating system will be checks this particular mutex here. Before going to take this one, mutex does means the full form for mutex is mutual exclusion. Mutual exclusion. So here they have taken this is the word MUT exclusion EX has been taken. So that is why it is called as mutex, MUTEX. So that is the meaning of mutex. That's all. There is no speciality of mutex here. Mutual exclusion has been taken into consideration. So in mutual exclusion MUT exclusion EX has been taken mutex. That's all. There is no speciality in this. Okay. Now let me write the piece of code here. So at any point of time, a particular mutex, in the presence of mutex, any process is trying to access or execute its critical section, it must be, I mean, the piece of code must be seen something like this here. While, so true, always it must be taken. So always it must be taken as infinite loop only, because how much code will be there with you, we could not understand. So that is why it must be true. It must be starts with only while true. Now here, acquire lock lock will be taken by this particular process. And then followed by if lock is accepted, this particular statement is successful. We'll write what is acquire lock after some time. We'll write after some time. Okay. Then if this will be acquire lock will be get succeeded, then so let me talk about critical section. Whatever the critical section you are trying to execute, that must be executed by the process. After completion of critical section, of course, it is your responsibility, process responsibility, to release the lock. Release the lock. Lock must be released. Okay. Critical section, after completion of this one, it must be release the lock. Then followed by remainder section. Okay. Then followed by remainder section. Okay. So this will be gets executed continuously. This is the piece of code where exactly will be executed by so mutex while any process is trying to enter into critical section. Okay. Now let us consider what exactly acquire lock and what exactly release lock. However, this acquire lock will be always trying to, let me take this. This acquire lock is always trying to take the, I mean, sense the mutex, the common point mutex here, whether it is false or true. So try to understand. I'm talking about false first. I'm talking about false first, then only true. When it is false, when the lock mutex value is false, of course, the mutex will be converted from false to true. It will be converted from false to true. Then critical section will be taken by that particular process. Please understand. Please understand. Okay. When it is false, so if it is false in the sense, yes, mutual exclusion, I mean, mutex lock is being available for you. Mutual exclusion lock will be available for you. Then it will be converted into so true. Then you have to do the work. Okay. Okay. So that is what it is being done here. That is what it is being done here. Now, when it is true, when the process, let me say this particular mutual exclusion value, the lock will be true, does means it doesn't go to execute anything. Your process will be waiting state until this mutex value should be comes into false. It must be waited state. Okay, it must be waited state. So that is what you are trying to do. That is what you are trying to do here. This is the actual scenario. However, if lock will be acquired, lock will be get succeeded here in the sense, obviously, your available, I mean, this particular mutex lock will be always make into so true, and then you have to do the operation. Then it will be do the particular value. Okay. So probably what I have given is slightly, yes, it is true only, slightly so wrong, I think. Slightly wrong here in this thing. Whatever the thing I have given, that is slightly wrong. When it is true, then it will be make into false and do some kind of activity. When it is false, it will be done waiting. Okay, that is the point. Let me write the particular piece of code, then you could understand what I'm speaking here. So you can see acquire lock of. So what actually we have to operate it here in the sense while not, of course, here they have used one particular variable as available. Mutex will be named as available. So available, okay. Then if this particular thing is true, if this particular thing is true, not available will be true, obviously. So look at this particular thing here. Available is the particular value which is false. Available, which is a particular value which is false. Not available here in the sense it will be considered as true. So until this particular available will be goes to false, until available will be goes to false, it will be done some particular operation. Okay, that is one. So let me give you very much clarity about this one here. So then after it will be goes to busy waiting. So here it will be just wait for some time. Busy waiting. Okay, busy waiting. However, if this particular loop will be gets terminated, then obviously available will be make into false. Okay, this is acquired. This is acquired. Whereas in a release, if you take release, it's very simple. Release is very simple. So release will be always make that particular release lock. It is very simple, pretty much simple here. That is available. So will be equal to true. So lock is available. Lock is true in the sense it is available so that you can execute. Lock is not available, that is false. Available will be equal to false. Mutex, what I have given here, mutex, that mutex is by default true. I'm very sorry for this because I was not taken this one in a formal way. It is actually by default, it is being set to true, not false. I'm sorry for this. By default, it is being set to true, not false. Sorry for this. Okay. And whatever the explanation I have given here also, that is wrong. I'm sorry for this. It is wrong actually. It is entire thing is wrong. Let me explain this one by using some piece of code here. So if available is equal to true, does means yes, available in the sense mutex. Mutex equal to true in the sense, yes, mutual exclusion kind of lock is available for you. That lock is available for you so that you can access that lock and you can do your own process. Okay, so if it is true, which is available. If it is not true, which is not available. Okay, that is the meaning. So I have misinterpreted myself. So that is why I have given something like that. However, if it is true, then it is available. If it is not true, that is false, it is not available. Okay, so that is the meaning here. So for this particular kind of thing, let me, so scenario will be, you have to draw in our examination something like this only. So this is the way you have to draw in the examination. But as far as my explanation point of view, I would like to consider something like this here. Right? Huh? Oh, okay. You have to explain this one only. Okay. But for my explanation point of view, I have to draw something like this. You can see this one here. So process one is there here. This is my process one. Process one is there here. You please draw this one, but you can interpret yourself. Process one is this one. Process two is this particular thing here. This is the process two. So let me write in a different way. So actually, you need to draw in our final examination something like this only. This is the way you have to draw in final examination. Please remember that. Okay. But for my explanation point of view, I'm writing this one here. Okay. There is one particular mutex. Mutex name is available. Okay. Mutex name is AVA available. So let me consider this is available. By default, this particular value is true. By default, this particular value is true. Okay. Now the scenario. You please take this particular scenario. At delta t1 time, at delta t not time, so process P1 is trying to take, let me write AL, that is acquire log, AL. Please write acquire log. You please write acquire log. You please write acquire log. You write here. You please write అంటే మధ్యలోనే రాయాలని రూల్ ఏం లేదు, మీరు ఎక్కడే రాసుకోండి, నేను రాసినట్టు రాయాలని లేదు. Please acquire log, trying to acquire log here. Now at delta t1 t0 time, this particular p1 is trying to acquire log in the sense, you please observe this particular scenario here. Now what is the available value? Available value is equal to true. Not available here in the sense, true will be considered as false. While false, where should I write? What kind of thing here? While false, obviously this loop will be goes false. If this loop will be goes false in the sense, next immediate statement is this one. Available will be make into so false. So log is not available for you. Understand? At delta t1 time, t0 time, p1 is trying to. I hope that you understood. Not true is false. While false, so false only. It will be directly goes to next statement. Next statement is available equal to false. Available will be converted into false. Now at delta t0 time, it has been done by the process p1, and continuously it is being done something like this. At delta t10 time, t10 time, so p2 is trying to take the acquire log. What do you mean by this one here? Delta t0 to t9. So t10, even t10 also, p1 is not completed its critical section. So p1 is executing its critical section. It is being executing. So executing its critical section. During during delta t0 to continuation. Delta t0 to continuation. Now at this particular time, delta t10, p2 is trying to acquire the log, mutex log that is available. Now what is the value of, try to understand this scenario here. What is the value of available? False. Understand what is the value of available? So which it is false. Since it is false, you can observe this one here. I'm erasing this one, and you can observe this one here. So this is the scenario. This is the total scenario for P1. Now I'm trying to write the P2 scenario. I'm trying to write. Now A value is false. A value is right now, it is false here. Not A will be equal to true. Not A will be equal to true. Look at this, what we have operated here, while not available. So it will be goes to true. Until what extent of time this is going to true? Until P1 is being updated right from false to true. Until P1 is being updated, so right from false to true. P1 false దగ్గర నుంచి true చేసేంత వరకు ఈ loop continuous గా infinite loop అయిపోతుంది. Because while true is true, so nothing has to do, waiting and so on. Hope that you understood. Now continue. So and so on, so forth. At delta, t some 60 or 65 time. So P1 has executed release log. RL. You please write release log. Okay. Release lock is being executed in the sense, what is the piece of code here? Release lock will be only one statement is available here. That statement is just available must make into true. Now this particular available will be converted from false to true by process P1. Okay, by process P1. If it is done at immediately at delta 65, after doing this one at delta 66, so P2 is continuously operating acquire lock continuously. Okay, delta t10 to t65, it is being gets operated acquire lock, but acquire lock available is false. Since it is false, it is not supposed to be access the lock here. Lock has not been allocated for P2, so therefore it is being under waiting state right from this particular place to this particular place here. P2 is waiting. Okay, waiting. Now at delta 65, this is for just example only. Delta 65, P1 is applied for release lock. Soon it is being applied for release lock. So what exactly release lock will be? Release lock will be, so just change only one statement that is available will be, so change from false to true. Yes, it has been true. At delta T6, so P2's operation will be get succeeded. Why? Why it is succeeded here? So available will be equal to true. Since it is true at P2, second time it is being executed here is available will be equal to true. Then not available is equal to false. While false, yes, condition is false, then immediately available will be make into false. Let me take some other color. Then you could identify what exactly being going on here. This is P2 color. So you can see this will be make into false. And at delta T6 time, so it has been again acquire the lock. It has been acquired lock is success. Acquire lock is success here. Then it is being entered into its critical section. So it has been executed right away from T0 to delta T65 units of time. Okay, then it has been started its critical section delta T66 to. So of course we did not mention. So T66 and so on. It's executed its critical section right away from delta T66. For example, it will be continued up to and so on delta T some 250. So the 250. So P2 will be gets operated. So release lock in the sense, obviously at 250, this particular thing will be converted from false to true, because release lock is always trying to make that particular available from false to true. Now lock is available for everybody. Lock is available for everybody. So therefore it will be accessed and it will be taken. So this is the scenario. This is the entire scenario. Unmute yourself and you can ask any questions. Unmute yourself, you can ask the questions. Did you get the particular point here?
Yeah. Yes, sir.
Remaining 3. Mr. Vijay.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Edana questions unnaya? Any questions?
No, sir.
Okay. If there are any questions, let me answer them. Otherwise, I'll go for winding up. Because చెప్పాను కదా, మీకు సెమాఫోర్ అయిపోయేంత వరకు బుట్ట టాపిక్స్ చెప్తాను, పెద్ద చెప్పను. సెమాఫోర్ దాటిన తర్వాత 2-3 జరుగుతాయి. ఓకే. ఇక్కడ ఒక చిన్న ఓకే, ఇక్కడ ఒక చిన్న కాన్సెప్ట్ కూడా ఉంది. ఆ కాన్సెప్ట్ టుమారో చెప్తాను. దాన్ని సెమాఫోర్ లో కలిపి చెప్తాను దాన్ని. ఓకే, నో ప్రాబ్లం. సెమాఫోర్ లో కలిపి చెప్తాను. So tomorrow I shall go ahead with semaphore, and let me open your syllabus again. So here it is, your syllabus. I'll go for this particular semaphore by tomorrow, and then monitors. Of course, message passing is very simple. It is doesn't make any sense here. In semaphores, you could get barriers as well. In semaphores, you could get so this busy waiting and sleep wake up. Everything will becomes under semaphores only. అంటే సెమాఫోర్స్ కు మునుపు వాటి యొక్క యాక్టివిటీని చెప్పి ఆ యాక్టివిటీస్ మొత్తాన్ని సెమాఫోర్ లో ఎలిమినేట్ చేస్తుందని మాట్లాడుతూ ఉంటాం. ఓకేనా? సో దెన్ విల్ బి టేకెన్ సెమాఫోర్ ఇస్ 1. రేపు మాత్రం 2 సెషన్స్ కి అటెండ్ అవ్వాలి. రేపు మాత్రం దానికి ప్రిపేర్ అయి ఉండండి. మానిటర్స్ రెండో రోజు. మెసేజ్ పాసింగ్ ఒక వెరీ సింపుల్ అది. తర్వాత డైనింగ్ ఫిలాసఫర్స్ ప్రాబ్లం, రైటర్స్ ప్రాబ్లం సింగిల్ క్లాస్. సో అంటే ఇది 2 సెషన్స్, అంటే టుమారోనే. మానిటర్స్, మెసేజ్ పాసింగ్ ఒక రోజు, ఈ 2 ప్రాబ్లమ్స్ ఒక రోజు. ఇంకో 3 days లో యూనిట్ మొత్తం లేపేస్తా, వితౌట్ మల్టీ థ్రెడెడ్ ప్రోగ్రామింగ్. ఇది కాకుండా చివరిలో చూద్దాం, మల్టీ థ్రెడెడ్ చివరిలో చూద్దాం. ఎందుకంటే వెరీ ఇంపార్టెంట్ టు గో త్రూ దిస్ పర్టికులర్ థింగ్. మెమరీ మేనేజ్మెంట్ ఈస్ వెరీ 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 ఇంపార్టెంట్. ఇది చాలా ఇంపార్టెంట్. ఇది అర్థం కావాలి మీకు. ఇది అర్థమైతేనే విషయం పూర్తిగా క్లారిటీ వస్తుంది. సో కాబట్టి ఇంకొక 3 days లో, రేపు, ఎల్లుండి, ఆవులెల్లుండి, సోమవారానికి ఈ మొత్తాన్ని కంప్లీట్ చేస్తాను. మంగళవారం నుంచి మెమరీ మేనేజ్మెంట్ స్ట్రాటజీస్ అయిన తర్వాత డిమాండ్ పేసింగ్ అనే ఒక కాన్సెప్ట్ ఉంటుంది. ఈ కాన్సెప్ట్ చాలా ఇంపార్టెంట్. అయిన తర్వాత దెన్ ఐ విల్ కమ్ బ్యాక్ టు మల్టీ థ్రెడెడ్. ఇది ఒక 8 క్లాసెస్ 9 క్లాసెస్ పడుతుంది ఇదంతా కూడా. అంతేలే, 8 9 పడుతుంది, అంతకంటే ఎక్కువ పడుతుంది. ఓకేనా? So that is for today's class. If any questions, let me answer them. If any questions, let me answer them. Otherwise, let me wind up the session.